Hey guys, today I'm going to be talking about the differences between arrays and lists and when and why you would choose to use one over the other. Quickly, I'll go over what the data structures are themselves. Fundamentally, we have the arrays. They are a finite size. You can index into them to read and write the data based on index. And then lists, they are an indeterminate length of pointers that are more or less chained together. Based on kind of how they are shaped, you will find that there's a certain context on when you would want to use them. So we'll do some runtime comparisons. First, we will go over the initializations of these data types. First, we have the arrays. They are more or less considered native variable types in GML, so they initialize very quickly, while lists are part of the standard library underneath the whole DS library. So they have a bit of overhead in order to work and initialize appropriately. So we can go ahead and run that, and you'll see the difference between creating an array and creating a list. It's actually rather significant to create 100,000 of each. It was 25 milliseconds versus 2 whole seconds. Next, we will look at the garbage collection versus manual de-allocation. So because they are native data types, more or less, arrays, you can just forget about them and they will destroy and deallocate on their own once the program is done running. There is no real overhead to that. While DS lists being, they have manual allocations underneath the hood, they actually do need to be deallocated. And I know GameMaker does attempt to make some sort of deallocation at the end of the program, but this is more so for while your game is running. If you have a game that's running on for quite a bit and you have some function that repeatedly creates lists, you'll actually start to see that memory build up, and to the point where things may even start slowing it down for your game, and it's just overall unhealthy for your computer as long as that game is continuing to eat away at your memory. So we can go ahead and run that. With the array one, there is nothing really going on in this loop. Like I said, it's a very, you can just assign a new variable to the array because GameMaker is loosely typed, and it destroys the array in that new assignment of whatever you hand to it. Cool. So here we took about 8 seconds just to even run that array, or run that loop. And then it took roughly, 10 milliseconds for 100,000 DS list destroys. That's negligible overhead. But like I said, you do have to worry about manual cleanups, not just at the end, but during your program. So that is something to consider. Then we will comment this out and move on down to access time. So one of the biggest pros typically of arrays is O of 1 access time, while standard lists take O of n, because you have to start at the head of the list and then iterate all the way through, and then the value you're seeking. But if you actually look here, you'll see that specifically to GML, lists can actually read faster than arrays. Wow, how is that? It's because DS lists are not standard vanilla linked lists that you would construct in another language. They have their own unique implementation under the hood, which I believe dynamically use arrays as well, so that lists can, in GML anyways, surprisingly compete with arrays, especially in value lookups. Now we'll come down here to the only real shining pro of lists is that it's kind of designed to handle indeterminate lengths of data. This is very useful, so that lists have an O of 1 growth, while arrays have a theta n resizing. So effectively, when you want to add to a list, you just append to the end add a new pointer, keep going, right? It's great. Fundamentally, that's how the data structure works. Well, with arrays, there's a resizing. So let's say I have these data pieces in an array, and then of an array of size 4, and then I want to append a 5th piece of data. Well, how do I do that? I actually have to create a new array of 5 pieces or 5 length. Then it copies the data over, and then it adds the new value. This is simply just from trying to add a new value. It has to create a new one of size n+1, add the new value after copying the data over every single time. So imagine if we did that 100,000 times. This may actually have quite a bit of overhead. We may actually have to wait like roughly 15 seconds for all those array regrowths happening under the hood versus the super fast list appendment. Yeah, here we are. Yeah, about 15 seconds versus 17 milliseconds. That's absolutely horrible. This could be the downfall of your program if you're not careful. That's why it's good to initialize arrays to the appropriate size nice and early. So when would you contextually use arrays versus lists? Arrays, I would say you would use it when you need quick bundles of information to be passed around. The best example I can think of is when you have a function that you need to return, that needs to return multiple values. You quickly throw them in an array, return that, and then in the function it was invoked from, you now have those 3 values packed together in an array. That is when you'd use that. And then lists, because they're so versatile, I would use them for more like global persistent structures. Like let's say there's soldiers that come on and off your screen and they dynamically add or remove from that global list. You don't know how many soldiers are going to be on your screen. You don't know when they're coming on. Order probably doesn't even really matter. So you just need a grouping of them together. That's when you would use a list. Here's also a specific to GML tip on how to handle lists. Because typically when you're dealing with linked lists, let's say you had like instances or structures inside the list that you want to handle. And you would typically just iterate through and then, let's say destroy that object at the head and then delete the head of the list and then keep going iteratively until the list is empty. But the thing is that because we now actually know that lookups in these DS lists opposed to classical linked lists have O of 1 lookup, it's actually better to just iterate completely through the list, destroying all of the instances along the way, and then at the very end just clear, as opposed to doing like this head pop delete thing that you would classically do in like Java or Python. Because now the real difference is that we just have 2 DS calls per loop versus 1. And we get, about 2,500 milliseconds for the more intuitive approach versus the 1,600 milliseconds for the refined approach. We also have no idea what kind of is going on underneath this DS list delete. Classically in a linked list, it would just pop off the head and shift the head pointer down, but who actually knows what GML's implementation of this is under the hood? We may be experiencing some sort of occasional array resizing or something like that. Yeah, that is the difference between arrays, lists, some of the runtime comparisons, when and why you would use them, and some kind of counterintuitive approaches on how you would handle these list iterations in a applicable approach. All right, that's it. Thank you guys very much. I appreciate it. Bye-bye.